Good day, ma'am. Good day, classmates. I am student number 27 and I will be the reporter of hydrologic investigations in determining subsurface resource. Hydrologic investigation is essential in identifying a reliable and economical source of water supply of required quantity and quality. So, hydrologic investigation will help us identify a reliable spot, an economical source of water to provide the required quantity and quality of source of water that we need. It refers to the observation and measurement of hydrologic factors in order to quantify the hydrologic cycle process. So in hydrologic investigations, we have reconnaissance investigation. A reconnaissance investigation is based on a review of existing information and examination of surface features at the site. The reconnaissance is made to acquaint the investigator with the nature and characteristics of surface features and conditions. So in reconnaissance investigations, we can encounter these things. General geology of the project site, it is like a map of the place that we need to investigate or that we want to investigate. Geologic conditions that influence groundwater movement and recharge. Surface features resulting from groundwater movement such as seeps, springs, and landslides. General character of streams and valleys including volumes of flow, stream banks and bed, steepness of valley grades and slide slopes. Groundwater development, yields, quality and use. Water well logs. Groundwater quality reports and data. So if we do reconnaissance investigations, we will encounter these things. The general geology of the project site and etc. and as follows. And we have preliminary investigations in doing reconnaissance investigation. A preliminary investigation is made to determine the geologic and hydrologic characteristic of the subsurface material. A preliminary groundwater investigation includes a review of the reconnaissance report, if available, geologic literature of the area, groundwater reports and data, and well drilling data and records. The investigation should establish the nature and characteristics of the subsurface materials, groundwater conditions, probable yield, water quality, and other conditions and features. So, a preliminary investigations helps us to determine the geologic and hydrologic characteristics of the subsurface resource that we want to investigate. But yet, it is preliminary investigation. It is yet a preliminary investigation. So, in doing preliminary investigation, we have to follow these steps, or we have to do these things in order to execute it. First, maps, imagery, field study, mapping, geologic sections, and report. First, maps. A study of available resource maps is an excellent way to start a preliminary groundwater investigation. Maps and other information may be obtained from state geological agencies, U.S. Geological Survey, local or county water management agencies, universities, and government agencies such as the Natural Resources Conservation Service. So, of course, if we do investigations in our water resource, we really need maps to start our investigation, because if we don't have map, we don't know where to start our investigation. So first, we really need maps. Next, imagery. Aerial photos and GIS data sets can be used to make initial interpretations of geologic structure, landforms, potential recharge areas, springs, land use, and vegetation patterns. So imagery, it is like hologram 3D version of a map of a certain place. And a GIS data is a geographic information system that stores data or that will show you the landscapes of the place that you want to investigate for subsurface resource. It is like a 3D kind of map that will help us, that will guide us where the rivers, lakes, or possible water resource located at. It is a very precise map or data set. Satellite imagery as well as light detection and ranging or radar data may also be used if available for the area of study. Radar data is also like GIS data, but radar data use lasers to lay out in a 3D version the landscape of the area that we want to investigate. Next, field study. In areas where stratified sedimentary rocks are exposed, the details of local structure and its relationship to possible aquifers in the geologic section must be determined. So, what is a stratified sedimentary rocks? Stratified sedimentary rocks is like rocks that are present in the Grand Canyon in US. That is a stratified sedimentary rocks. So field study, this is done by measuring and plotting the altitude, strike and dip, and elevation of the exposed strata on the map of the area. So strike and dip, it is like if you have a surface, if you have this surface and you have a horizontal plane, this here, the intersection of the horizontal plane and the surface area, let's say example, surface area of a rock. The intersection of horizontal plane and the rock surface area, it is called the strike. And the dip, it is the angle below the horizontal plane to the existing or the exist surface area of the rock. It is the angle. That is the dip. So next, mapping. A geologic map should always be prepared on the best available base map, including aerial and superficial geology, structure of bedrock and stratification, folding, schistosity, faults or fractures, surface groundwater features including springs, seeps, swamps and marshes, sinkholes and disappearing or reappearing streams. Legend listing all information shown on map. This includes a brief description of characteristics of aquifers, aquicludes, and other pertinent information. Locations of wells, well record data and logs will be included in reports. So mapping, this is the way that this is a way that we will store our newly get data from our investigation. Like if pag muadto na ta dito sa site, then natay nakita ng mga bagong source of water, or we have discovered new sources of water like new rivers, new lakes that does not exist in the past data. This is where we include it in our new mapping or in our new map. We must include it for our investigation. Next, so this is the United States map in their hydrologic cycle or hydrologic resources. The aquifers modified from principal aquifers USGS 20. This is an example of mapping to them in US. This is where you will know where the swamps, the lakes, the rivers located at, and by this it will easily help us investigating the subsurface resource that we want to investigate. LIDAR, elevation data at topographic maps. The other one are the LIDAR data that uses laser to lay out the map. And the other one is the topographic map, which is commonly done manually. That is the topographic map. So this is the satellite imagery used in geological mapping. The satellite. So of course we have our new technologies, very high-tech technologies, such as the satellite in outer space. But we also need to do it by ourselves, like this, like that, yeah. Because there are certain cases that the satellite will not capture a newly built or a newly formed river or lakes, because it cannot capture it. I don't think, but the size does matter. If we have discovered a small river but it is also a water source, that's why we can manually insert it on our map. Next, geologic sections. To complete and interpret the information on a geologic map, one or more geologic sections and fence diagrams should be prepared based on log of wells, test holes, geophysical studies, or other related information. So geologic section should be prepared based on log of wells, test holes, and geophysical studies. So geologic section is like 2D drawing that, for example, this is the surface of the earth or the surface of the soil. Then next are the clay soil, next the bedrock, next the water resource, underground water resource. That is a geologic section. So section by section by section. So and it also tells, and fence diagram should be prepared. So fence diagrams is like geologic sections that are designed like fence. So this is our 2D geologic section. If you do a fence diagram, you will add the next, or kay dili man pod nato ma-determine jud na ang one side ang sa one area kay isa ra gyud na ka geologic sections. So mao na magbuhat og fence diagram kay para makabalo ta sa lain na area kung unsa pod ang sections ito, basin dili pareha sa first na geologic sections na atong nakuha, basin lahi-lahi ang pagkasunod sa pika. So mura na siya kanang kung magtanaw ka sa front view niya, mura siya framing bitaw na yan nga ana. Mao na ang geologic sections, murag gisurot nimo, murag mga geologic sections gyapon siya na connected kay para ma-determine kung unsa gyud ang sections by sections sa per area, kay dili man gyud parehas tanan na ang pagkasunod-sunod sa sections, di ba? So mao na magbuhat ta og fence diagram. So next. So this is the example of a geologic section. So see, first the glacial deposits. For example rin siya, lac post dolomite. Murag ana siya, murag ipakita niya ba unsang sulod or unsang makita nimo kung mag-cut kibali ka sa lupa. unsay pagkasunod-sunod niya, sections by sections niya, mao nang geologic sections. So mao ning 3D version sa geologic sections. So first, sand, gravel, boulders. Next, caliche bearing sediments. Next, clay and di maklaro. Kung basta mo na murag ipakita gid nimo unsa ang mga section sa lupa sa ubos. Next, ang final part sa preliminary investigation, which is ang report. A geologic report generally following the outline in this chapter should be prepared for a preliminary groundwater investigation. The report should include a concise discussion of groundwater conditions, interpretations, conclusions, and recommendations for solving any problems. So after ta mag-investigate, syempre i-report man gid nato na. In our report, we will state or we will discuss the groundwater conditions that we have investigated, the interpretations, our conclusions in our investigation, and our recommendations for solving any problems or issues at that certain place that we have investigated. Because we do not know if it can cause issues in the near future, so we would recommend some development plans to solve the problems. So next in our hydrologic investigations, we have the detailed investigation. A detailed investigation collects data for making sound geologic interpretations. Specific site materials and groundwater conditions are documented to provide sufficient subsurface information for the design and construction of project measures. Detailed investigation include a review of the information covered by the preliminary investigation, collections of additional data, preparations of a complete report, including logs, maps, geologic sections, fence diagrams, and results of field test and collection and laboratory analysis of samples. So mao na ni katong murag this will be the final investigations, and this will be the most detailed investigations, and detailed investigations will use the data from our preliminary investigations from our preliminary investigations. In brief, detailed groundwater investigations consist of drilling, sampling, logging, describing, and classifying all strata that will influence groundwater hydrology. Next, pressure testing for in-place permeability and seepage through fractured rock and voids in soluble strata where control of seepage is important. Ascertaining the influence of structural geology, faulting, folding, and fracturing on transmissibility of groundwater. Installing piezometers or observation wells in hydrologically significant strata. So what is a piezometer? It is an electronic device that measures pore pressure of the water in a certain ground. Next, so in doing detailed investigations, we must do data collection, correlation, interpretation, and lastly, report. So first, data collection. Geophysical survey, seismic or various types of electrical resistivity equipment can be used to determine depths to bedrock and depths to a water table as well as fractured zones. So, geophysical survey, it is a way to know the depth to a bedrock and depth to a water table in a certain place or a certain area that we need to investigate. Test drilling. Detailed plans should be prepared showing locations and depths of wells desired to obtain sufficient information on the ground on the position depth, gradient, and nature of the aquifer or underground cavernous or water storage area. Sampling. When drilling is done, during the detailed investigation, samples should be collected to determine gradation, storage capacity, chemical composition, and permeability test of unconsolidated materials and rock formations. Next, assist in the correlations of horizons or rocks formations. Determine the nature and extent of faulting, jointing, and cavernous conditions. Determine the possibility of surface subsidence or collapse of certain horizons. Determine the nature of an aquifer, its storage potential, productive capacity, the transmissibility of groundwater. So, after drilling, we will collect samples from our drill site to determine such data like gradation, storage capacity, determining the nature of an aquifer, its potential to store water. So we know what is an aquifer. It is like a storage area of water in a certain land. That is an aquifer. Next, tracers. To use tracers in groundwater investigations, the upstream or intake area must be accessible. If not, drill holes or test pits will need to be prepared. The discharge area also must be accessible, or holes or pits will be needed at a measured distance in the down gradient direction where water samples can be quickly observed or tested. Next, in our detailed investigations are correlation and interpretation. After reviewing the available information and completion of geophysical, drilling, and excavation investigations, detailed geologic sections and fence diagrams can be prepared and correlated. The data obtained should be complete enough to provide accurate correlations and geologic conditions and to supply the desired information on groundwater showing stratigraphic sequence, geologic age, thickness, character, and compositions of unconsolidated and consolidated strata. So here in correlation and interpretation, this is the time that all the data that we have gathered will be interpreted to come up a result of our investigation yeah. So next, report of detailed investigation. A detailed investigation contains collected data on observations made and other information assembled during the investigation. The report also includes interpretations, conclusions, and recommendations made from this factual data. It is like the report in preliminary investigation, but this is a detailed investigation and it will be the final investigation to be used, or investigation report to be used in our hydrologic investigations in determining subsurface resource. It contains all the conclusions, all the recommendations, interpretations from the data that we have gathered based on the results of our investigation. Conclusions may indicate that the problem is the result of natural conditions such as excessive erosion, valley filling, stream piracy and glaciation, or that the conditions are induced by natural causes of works of man such as channel degradation, land movement, earth collapse, or formation of natural levees. So that's all for my report in hydrologic investigation in determining subsurface resource. And thank you for listening and have a good day.